Thermoforming takes an extruded sheet, anneals it to a zero stress state where it's just below its glass transition point, and then we thermoform it around a tool that's typically about 160 degrees Fahrenheit.
We do vacuum forming, pressure forming, and twin sheet forming, as well as plastic fabrication and some secondary operations.
Wall thicknesses go anywhere here from about 80 thousandths thick to 780 thousandths thick, almost 1 inch thick.
It is some of the best technology out there to make large parts, specifically when you have to have multi-layers or low stress, because we are not an art, we are a science, it is repeatable.
Maybe I should explain, all of this is vacuum forming. All of the material is heated and then vacuum evacuates the trapped air. In some operations like this, we use a female mold and we pressure form it.
So pressure forming allows you to get the look of an injection molded part without having to have super high volumes, and allows us to add texture to our tool.
This part was converted from metal to plastic. We do a lot of conversions because of the cost of metal, the cost of stainless steel, also the cost of finishing metal these days. This part was extruded gray, formed gray, and it's ready to go. All we need to do is put a pad print or a silk screen on the front of it to finish the decoration.
The biggest benefit of thermoforming over injection molding is time to market. We can really get your product out the door quicker. From time to the prototyping, it's only 2 weeks we can have something out the door.
Turnover is only a couple of hours to go from running this part to running this large polyethylene part that you see behind us. Changeover in this industry is very quick as opposed to other processes like injection molding or roto molding.
When you're blow molding or you're injection molding or you're roto molding, you're taking it up the resin to a melting point, and then you're slamming it into a cold tool to chill it, and that imparts a lot of stress in the part. So what we will do in thermoforming is we will exceed the properties of the raw resin normally, if processed correctly.
This is a large part made out of high-density polyethylene. It's used in the drainage industry. Yes, we can get up to 12 feet. We do a variety of different things, from the high-density polyethylene parts that you just saw to parts like this drain pan made for air conditioning units made out of polycarbonate. Very rigid material, very durable material. This part is formed off of a male tool. This part is made out of ABS. This is a medical cart top pulled into a female or a pressure forming mold. We take a single sheet of material and we pull it into a tool, so this is your tool surface. We have the texture, we have the detail, and then these pockets are smooth. There is no texture in these pockets.
So today I'm at our Conyers, Georgia plant, which is about a half hour outside of Atlanta.
We've got 3 plants. We've got 2 thermoforming plants and we've got an extrusion facility.
This facility is 100,000 square feet, a high ceiling, lots of power, and it's down in the great state of Georgia.
Our plant in Georgia has the same capabilities as our other plant in Metuchen, New Jersey, but it's newer, it's got some brand new equipment.
Our emphasis is going to be on automation. We're going to be implementing a lot of robotic handling of parts and automatic loading of machines, because we're going to be running parts out of hundreds of thousands of pieces rather than 2,000 or 10,000 parts like we do in New Jersey. The parts are higher volume, bigger parts.
We have the ability to run the same tools in both plants. Really, there's 2 reasons why. It's a capacity issue and a safety issue. The capacity issue is if somebody needs things faster, we can make it faster because we would make it in both plants. And we could make it closer to you to save freight.
Something that sets C&K Plastics apart is that we partner with our customers.
Well, the big thing is our customer service here is almost like kind of a family care type deal. I get to know them very well. I try to visit even if there's nothing going on, kind of connected in case anything ever pops up, we can be there to help.
And we have the ability to help them manage their forecast and keep raw material, whip parts, and finished goods in stock and ship according to what they need.
In Atlanta, we got shipping to pretty much the whole Southeast directly, and we have railheads within a half mile of the plant that we can ship to the West Coast.
C&K Plastics is a family-oriented company, and I'm living proof because I'm the 3rd generation carrier to work at the organization. My boss and my dad, Bob Carrier, is also an engineer, and he really knows how to run this place.
The great thing about our owner, Bob Carrier, is he's an engineer by trade, and he runs the company from an engineering perspective.
I was a geek, and I enjoy being an engineer. I guess I still am a geek and still an engineer. Now I spend too much time with my balance sheets, but the engineering and being out on the shop floor is where it's at. It's fun. We're very customer friendly. We're very focused on new technology. I think that's the way to go. Good tooling, good equipment means good parts.
And the last thing that you would expect to see here at a vacuum forming company is carpet, and we vacuum form this.
And as you can see here at C&K, we actually formed a carpet for a car manufacturer. So they want to thermoform the rug to help fit and hold the tight lines as you see in a car. You want some tight lines to make it look like it was almost formed into the car.
One of the exciting things we're working here at C&K is incorporating long glass fibers within the structure of the thermoplastic. This is a twin sheet part with the glass fiber embedded in it. Our application is to try to compete with thermosets and metals as far as the modulus and the strength of the cover is.
As you see here in our warehouse, these are large drainage parts. They're made out of high-density polyethylene. As you see, there's a lot of them here. We'll be able to deliver parts when you need the parts.
So we can fulfill orders just in time.
The only way to do that is you get really, really lean or you keep something in stock. So we try to balance it between the two. Be lean so you can run short runs and make money on it, but also keep the high runners in stock.
These are 5-axis CNC machines. As you'll see, we're starting to convert to all closed door machines for safety and for the cleanliness of our plant. Right here, we're setting up the trim fixture for this part that you see us forming right here. He will take the part off the vacuum forming machine, he'll bring it over here, and then he will do the trim. Trim fixtures are made out of a product called Ren board, which is an epoxy type material. It's very inert, it doesn't attract water, it's very durable, but it saves the customer money. And these parts right here are the part that he will be trimming in just a few minutes.
We are very environmental friendly.
From the environmental point of view, the best thing about thermoforming is that we don't chemically alter the material.
This material is reground scrap that we will send back to our supplier and have it turned into sheet again for another project.
Another thing we do here that we're really good at is returnable packaging. We actually make this and car parts fit right in here for the customer to have and send out to his customer and return it back to keep using it. In fact, here it is with the transmission parts already in place. As you can see, they fit very nicely in here.
Here at C&K, we're working on many projects to have reusable plastic pallets. Right here, he's welding a new cap on these pallets. This is an injection molded pallet. The customer needed it repurposed. It was made for one thing. Working with our engineers, we came up with a new application for this pallet. Barrels will be shipped on this pallet.
We're especially proud of this machine from Canon.
It's a zero sag.
This is one of the first in a custom thermoformer in the United States.
So when we heat up plastic, it's got a melt transition point and it creates a bag, is what we call it in the thermoforming industry. And it's a big sag. So when you're doing a very shallow draw part, it's very difficult to do because the piece stretches out and now you got to contain it in a very shallow draw part. With the zero sag machine, there's no sag at all.
Well, when we pull the sag out of the material, there's less chance of thinning. We keep a much more consistent wall thickness on the plastic part.
We got hundreds and hundreds of years of experience in the thermoforming industry working at C&K Plastics. We've been there or done it before, and if we haven't, we're really going to be interested because we're going to want to try something new.
We can make the part, we can stock the part, and we can ship it when you need the part shipped.